All right, hello everyone. Welcome to the command-based programming session. Today we will be talking about the whole command-based paradigm of what FRC programming is built upon. Okay, just to clarify, this is not a programming tutorial. This already assumes you have knowledge of Java. Okay, so if you haven't already, take AP Computer Science A. Let's just dive right in, all right? First, we got to differentiate between what a command and a subsystem is, okay? A subsystem is a part of the robot, like the arm, the drivetrain, the wrist, okay? These are the physical different parts of the robot. But a command are the actions that a subsystem can do. Like a subsystem is a wrist, a command is a move wrist. A drivetrain is a subsystem. A command is drive forward. Okay? This is what a command looks like. It's a little hard to see. Sorry about that. In a command class, let's see if you can turn off lights. Yeah. How about all of them? Yeah.
Then they can't see you. But
I don't care. That's fine. You just need my voice. All right. In a command class, there are 4 important methods, okay? Initialize, execute, is finished, and end. So a command has a life cycle, and it goes in these steps right here, these 4 steps go in a sequential order and in an order that is meaningful, okay? So when a command is first scheduled, initialize is called, and it's called once. And so right when the command is scheduled, it calls initialize, and that's called once, okay? And then every 20 hertz or 20 milliseconds, that's how fast the loop is on the robot. This command will loop. This command will execute repeatedly every 20 milliseconds. What it will do is, every 20 milliseconds, remember this is a loop, it will run the execute method. And then once it runs the execute method top down, it will check, it will call is finished, which returns a Boolean. If it returns false, whatever condition you put in here, if it returns false, this command is not considered finished. So it will repeat the loop. It will continue looping every 20 milliseconds and executing this command. However, if is finished returns true, it will end the command. And ending the command, what it will do is it will prevent it from being called further and like take it out of that loop, unschedule it basically. And right at the end, before the command completely dies out, it will call this end method, which you can put any code of what do you want to do when the command ends, okay? Any questions about this? All right. Here is a simplified diagram. Start off with initialize, then you execute the command. Is it finished? Is the command finished? If no, come back and execute the command, and it will just constantly loop like that until the command is finished, then end. All right. Okay. Inside a command class constructor, there's a very important line here. Add requirements on the bottom. Add requirements is a method part of the command base superclass, and what it does is it kind of claims the subsystem. Once a command is scheduled, like say drive forward command, right? Drive forward command, what subsystem should it claim for itself? It should claim the and what I mean by claim is like reserve, okay? You're placing a reservation on the subsystem so that no other commands can use it. So take the drive forward command, for example. That's just an arbitrary command that I made up. I would think that you would want to do add requirements swerve subsystem, right? Or whatever your drivetrain subsystem is. Because you know that's the subsystem that you want to reserve in order to run this command. Yeah, so this is very important because it prevents conflict. It's really easy to miss because your robot won't give you an error if you miss this add requirements, but it prevents a really important thing. where if you have one command already running, telling the arm to go to 90 degrees, and then you schedule accidentally another command telling it to go to 0, what do you, like, the robot is going to be conflicted, and it's probably going to crash, right? Any questions about add requirements? All right. Let's talk about some functional programming concepts, okay? So this whole command-based programming relies on a lot of functional programming concepts, and you don't actually learn about this in AP Comp Sci. Because what you learn in AP Comp Sci is like Java 7 and below, and this stuff is Java 8 and above, okay? And so I'm gonna go more into depth into this, into these concepts, and so please raise your hand if you have any questions, right? So the concepts that we're gonna go over is what is a function, what is a lambda function, what is a supplier, and what is a method reference, all right? First, a function. A lot of you have taken math. I think everyone here has taken math. A function is something that has an input and an output. That's it. That's really it. For our purposes, I know the equivalent of what a function is in Java is called a method, but from now on, I'm going to refer to all methods as functions. You'll see. Basically, yeah, a function is something that takes in an input, processes it in some way, and spits out an output. Any questions about this? Cool. A lambda function. Let's talk. Actually, before I start talking about lambda function, let's talk about a regular function right here. And yes, I know this again. This is a method in Java, but I'm going to refer to this as a function because technically it's the same thing. It takes in an input, returns an output. All right. This regular function right here, which is a method, has a return type. Well, this one has a return type of void, but it could be a Boolean, int, whatever type. It has arguments, and these arguments have types too. This function right here takes in one argument, so arg1 is an integer, right? It has a function name. It's called a function. I could call this, my func or whatever. And most importantly, it needs to be defined in its own code block, right? You can't embed. If you're taking an AP Comp Sci, right, you know that you cannot embed a function. You can't embed a function inside like an if statement or in another function, right? It needs to be in its own little defined code block, right? Now, a lambda function looks something like this, all right? Parentheses, arg1, parentheses, weird arrow, curly braces, all right? This is what we call a lambda or anonymous function. They're synonymous, right? Lambda and anonymous functions are the same thing. Notice there is no return type. This does not define a return type. There's no void. There's no int. There's no Boolean. It does not define an argument type. arg1 it is not explicitly clear what the type is. Okay. It does not have a function name. It doesn't have that like function, like that name part of the function, and thus that's why it's called an anonymous function, because it doesn't have a name. And it can be defined in line. And like to contrast with normal functions having to be defined in its own code block, you take a look at this. This.driverController.y while true new instant command. Look, parentheses, weird arrow, curly braces. That is a lambda function. That's how you kind of identify a lambda function. That weird arrow is very prominent of lambda function, right? And it can be defined in line. Notice this function is literally like an argument of this instant command constructor, which is strange. It's not, defining its own code block. It's like smack in the middle. It's in line. All right. Any questions about what a lambda function is? Anything you want me to clarify? I know this might be a new concept for most of you. Yes?
So it does the same thing as a function?
It does the same thing as a function. A function is something that takes in an input, returns an output. This guy right here, this lambda function, takes in an input called arg1, and there's no code inside here, but it could return an output or an output of void, which is nothing, right? Yes.
Why is this useful?
Why is this useful? That's a great question, Carson. I have 10 more slides explaining why it's useful, all right?
Good.
Any other questions? Cool. Let's talk about what a supplier is, all right? A supplier, right here. And notice these carets or like less than, greater than symbols. You've seen these in array lists, right? Like how you say array list string, right? That means an array list of strings. Supplier double means a supplier of a double. Okay. A supplier is a lambda function. And the reason why we call it a supplier is because you give it nothing. The input is nothing. It is void. It is nothing, quite literally. And the output is always a value. The reason why it's called a supplier is because if it fits a supplier has a strict definition in Java. A supplier will mean that it's a lambda function that takes nothing in as arguments and returns a value. It has to return a value. And why it's called a supplier is because like you just you execute that function and it will supply you with a value, right? So take for example this. So we just defined a variable here, supplier double x speed function. This is what x speed function is right here. This is the supplier that we defined for x speed function. It is a lambda function as denoted by the arrow. The arguments, there are no arguments, as we said, no input. And what it returns, there is no explicit return statement. If you just specify a value right here, if you just specify a value, that will be the automatic type that is returned, okay? There are exceptions to this rule, as in like how you can explicitly return a different value. We might get into that, okay? But basically, yeah. So this is your input, which is nothing, and the value on the right of the arrow is your output. And notice it calls this .driver controller .get left y. You could probably assume that get left y will return you some double that represents what the percentage of what your left joystick y axis is. Okay. So this entire thing again is your supplier. You ask the supplier, hey, give me that value, and it will go and fetch the left y at that specific moment in time and return you that value. Okay. See, every time you do whatever the supplier is, .get. You see right here, x speed function .get. Every supplier has a method called .get, and it takes in no arguments. That makes sense because the supplier here takes in no arguments. All you do is just ask. You just ask the supplier, hey, give me the value, right? .get. It will execute the function. It will execute this lambda function here and take the return value and give it back to you. All right. And the most important thing here is that it doesn't return you like a fixated value at some random point in time. Every time you call the supplier function, it will go out and retrieve the live value at this moment in time that you just called the supplier. And yeah, that's kind of the power of it. Any questions? Yes.
So like, why can't you just do .get left y? Why do you need a whole supplier function for it?
Yeah, so you're saying like x speed function .get and then in some parentheses the .driver controller get left y? Or like, sorry.
No, can you just
Yeah.
replace
Replace the
X-
the
X function dot get parentheses with this driver controller
Oh,
dot.
yeah.
Why can't you just do that? What's the difference?
Because in this context, this chunk right here, the supplier definition right here, is in robot container.java, robot container has access to the driver controller, to the Xbox controller, okay? But this down here is inside a command class. This command class only has access to the subsystem that it needs, which is the drivetrain subsystem. It does not have access to the Xbox controller. And thus, what the drive command looks like is that in the constructor of the drive command, it takes in one of the arguments in the constructor is a supplier double XSpeed function. And in robot-container.java, when you're creating a new instance of that command class, one of the arguments that you need to pass into the constructor is a supplier this XSpeed function. This line of code is what you put as the argument to the drive command object constructor. Do you want to see a live example, or do you want to see like the code?
Yeah.
Cool.
I think I know. I think my understanding is that when you construct the command, right? You say go command. If you pass that parameter as it says this drive controller dot get lex y, it's going to be at that point when the command is constructed. That's the value you get. But when you execute it later, when you actually needed it, is when the command is executed, it's actually going to go get it at that moment when the command is executing, not the time that the command is constructed.
That's absolutely right. Yeah.
See the difference?
That is definitely probably the more important one. I definitely missed that. Thank you. Because if you create a new if you create a new drive command and pass in this drive controller dot get left y, at that moment when it creates that object, it will grab that value of get left y, but it won't update that. It won't update that. But passing in a supplier here, will allow the swerve joystick command here to constantly ask the supplier, hey, give me this value at this moment in time. Okay, so this is swerve joystick command. This is swerve joystick command, the class for the command, and one of the instance fields here is XSpeed function. Is XSpeed function right here, right? And notice in the arguments, one of the arguments is a supplier of a double XSpeed function. Okay. And now let's go to robot container where we actually create that swerve joystick command. That supplier of XSpeed function is this. Don't worry about like the X and Y. That's not what's important right now. Basically, your question is why is it passing in a supplier, right? Because you're not passing in to this swerve joystick command. You are not passing in the value of the get left y at whatever moment in at like the moment in time that you are creating the swerve joystick command object. You are passing in a supplier, which is basically like a guy who can get that value for you at any moment that you ask him to. Okay. Because remember, this command, this execute, will run multiple times per second, once every 20 milliseconds, right? And every time you call execute, you don't want some value of the joystick in the past. You want the value at this moment right now. But the way to get it right now is by having a supplier go out and fetch that value for you. And that's what this supplier does right here. It will, when you do .get, this function will execute this line right here, the get left y. and it will grab that value and return it back all the way here and get that live value for you right now.
Okay.
Yes.
How does it differentiate between getting the y versus getting the x?
Yeah, so don't, wait, sorry, like, how did, like, the x speed function, the y speed function?
Yeah, well, can you go back to the other one? Because, it just looks like they're both set to parentheses, and I'm confused as to how, like, when you call dot get, how does it differentiate or, like, know that you're asking for the y versus asking for the x?
Yeah, so this is no different than passing in like a normal argument to, it just depends on the order of the arguments. Notice the first, or like the first argument is the swerve subsystem, but the second argument is the x speed function. The third argument is the y speed function, okay? And again, don't worry about the y and x stuff, that's like robot axis stuff. But the first argument of swerve joystick command is the swerve subsystem. That matches, right? Right here. The second one is supplier of x speed function. This is the second argument, which is a supplier of, and we call it x speed function. And then the third argument right here, supplier double y speed function, is this one right here. It's simply defined by the order of which you pass arguments in. Okay?
Yeah.
They're like modal variables, sort of.
Yeah.
Does that help?
Like the set default command, or wait, can you go back
To
to the, yeah, like the, what is that called? Swerve joystick command is
Yeah.
like a variable thing.
it is not a variable.
No, that's
it
a
is not
constructor.
Okay, wrong.
It is a
understanding.
constructor. It is not. Yeah, it is a constructor.
So instead of passing the variable once, you're creating like a separate little thing that will go and grab a value from a set, sort of, it's kind of like a superclass, but it's like where you're pulling information from. So you've got the robot container, which contains all the information about the robot and also about the joystick, and you've got the command class, which doesn't contain the information about the joystick. So when you write the command within the robot container, you're going to make that new class, but you're giving it information that's known in the robot container through the suppliers to the other class so that it can be manipulated. Make sense?
Well, think of it just the whole function as the argument. The whole function definition becomes the argument.
Yeah, so
That's basically how you think about it.
that's a little tricky though, because
Yeah.
because like the whole like passing first order function passing in stuff is like hard to wrap your head around.
Wait, what was the one with the where you made the suppliers?
Where I made the suppliers right
Yeah,
here.
what is that one called?
What do you
Or,
mean?
like what branch?
What branch?
Oh, in the
Main?
Yeah.
Main
Master?
branch. Yeah.
Okay.
Yeah, it's in robotcontainer.java. Yeah, you can poke around in that. You want to look at robotcontainer.java and swerve joystick command.java. Okay. All right. Anyways, anyone have any other questions about suppliers? All right. Shall I continue?
Moving on.
Moving on.
Yeah?
Okay.
Okay.
No worries. And I can, Charmaine, I can totally, I can totally explain to you more further after. All right. Number 2, a method reference, or in this case, we're going to call it a function reference. Technically, it's called a method reference, but I don't want to confuse you guys with method function. They're all the same thing. Okay. All right. Let's see. Okay, so if you take a look here, swerve subsystem 2 colons get pose. This looks really weird. What is this doing? Okay, this is what we call a method reference, a function reference. Okay. I am gonna call this a method reference because that is the technical name for it. Okay. A method reference is denoted with the object of the this method specifically get pose is a method that exists in swerve subsystem. So you're not just specifying any random object. You're specifying the objects of whose method you want to, of whose method reference you want to pass in. Colon, colon, 2 colons, right? Remember? 2 colons, and then the method name. All right. This is not the same thing as doing swerve subsystem dot get pose parentheses. That is to execute the method. That is to actually run the method and get whatever values back. That's not what we're doing here. We're not executing the method, okay? We are only providing the reference of that method. Give me a thumbs up all the way up or thumbs down or somewhere in the middle of how familiar you are with references, like variable references and stuff.
Is it like the, wait, is it like the,
What do you think references? Aria.
Like you're trying to get what that
think
method
it's the
does, but you're not
memory.
actually trying to get execute it. I guess.
You're close. You're
Yeah,
close.
okay.
Yeah, Justin?
Anji, yeah, what do you think?
Sorry, my bad.
Charmin, whatever you guys, what's your thinking of reference? What's a reference?
Okay, but is it like,
What is a reference?
like when you have the Java print an array and then instead it gives you like a bunch of random
Mm.
stuff?
Okay.
So,
Justin?
yeah.
You were saying something?
is it the memory address?
Yeah.
It's basically
Yeah,
memory
so
address. It's a location.
Yeah, exactly.
Something else.
But I'm not going to go into memory addresses and whatnot. I'm not going to go into that, okay? Basically, you can think of the, somewhere around, somewhere in your code, your method exists in a location, in a specific location, like inside your class, right? The reference is not executing, okay? It's simply, you're passing in the location of where the method is. Kind of like you're driving down a road and you see a new restaurant that just opened, okay? This is not you going to the restaurant. You're like, hey, I'm hungry, let me get some dinner. Okay, this is you remembering, hey, I want to go visit that restaurant in the future because that looks really good. I'm gonna remember where that is. Oh, it's like in the intersection of Boston Post Road and some street, okay? That's the location of the restaurant. And you just remember that. You just keep that in your head. That is a reference to that restaurant's location. You are not actually going and visiting the restaurant. It's just where it is, okay? Same thing with this method. You're just recording, like this method reference is simply like the restaurant's address, right? Where is it in the world? And so what this swerve auto builder does, is the first argument here is a method reference. And the purpose of this, you can think about you can think about this acts similarly, very similarly to a supplier, where the swerve auto builder, you're creating this whole swerve auto builder object right now, but you're not running the auto path right now. But when you're planning everything and creating the swerve auto builder object, the swerve auto builder says, like, when I run this auto path, like in the future, when I'm actually executing this auto path, I just want to write down and remember, just in case, just so I don't have to ask you again, who can I ask in this world? Who can I ask? Where can I go to get me the value of the current position of the robot, right? Who can I contact to get the current robot's position? And what I'm saying to the swerve auto builder is, hey, you can go over and ask this guy. This guy is over there. It's at this location. Remember, this method reference is like a location. All right. The guy you can ask is over there, right? And the swerve auto builder this is not the same as the swerve auto builder explicitly asking what is the current robot's position right now. He's not asking me. Okay. I just told the swerve auto builder the location of the guy to ask. Anyone have any questions about what a method derivative? Yes.
So why do you need to ask it for the location? Like why wouldn't you know the location? Is it like because you can't access the location, so you don't know the location? But like if you can't access it, then why?
Yeah. So this acts. This is a similar question, to why do we need a supplier? If you call swerve system dot get pose parentheses, that will execute the get pose method, and in that exact moment in time when you are creating this swerve auto builder object, you are giving the position of the robot at this current moment in time, right when we're creating this auto builder. But the moment in time where the robot actually starts executing the path is not necessarily now. It could be in the future. And when it is in the future, if we just passed in the position of the robot at like this point in time, when it gets to the future, when it's actually trying to run the auto path, that position is outdated, assuming that like the robot is moving around, right? So again, if you call the method directly, it will tell you what the position is right here, right now, but it won't tell you what it is in the future. And that's very limiting because the auto, like an autonomous routine wants to constantly ask for where the robot location is. You need basically a live location of where the robot is at any given moment in time. So that's why you pass in a method reference, which kind of acts as a supplier, which is you don't give it the value itself of where the robot is. You give the auto builder the contact of the guy that the swerve auto builder can ask to get the robot's location at any given time that you call. Anyone have any more questions? Yes.
So what's the difference between the method reference and the supplier?
To be honest, they work pretty much the same way. Yes, they work pretty much the same way. They do not take in any inputs and they return an output. And it's simply yeah, you can. I'm pretty sure they are like two different ways to denote the same thing. Okay. I may be wrong on that. Let me see after. Okay. Yes, Charlie.
So in the future, what does it look like when it's being used? Like why can't you just put the dot get pose in the future?
Because there's no such thing, because Java cannot look into the future, right? Like right when you create the object, right when you create this swerve auto builder object, it is creating the swerve auto builder at a very specific moment in time. Like right when it gets to this creation of the swerve auto builder object, that in itself is like the moment in time that is creating that object. But that does not mean that it is currently running the auto path. You are just creating an object. That is different from actually executing the auto path.
Can you show the code actually using the reference?
Sure. Okay, so the thing is, Swerve Auto Builder is not my code. That is, path planner stuff. However, where is it? Wait, I think it is in.
And Aria, you had a question?
Oh yeah, I was gonna ask like, if it's just a reference, like when you actually need it, how would you call that position?
Right. That's okay. So this will help that as well.
Okay. So I'm pretty sure because I'm pretty sure because I haven't looked into Path Planner's code specifically. This is a separate library, but basically I'm pretty sure it acts in the same way where it is a supplier, because that method reference it takes in no inputs and returns an output, and thus in the constructor of Swerve Auto Builder, I'm pretty sure it's a supplier, and you can just do .get or something similar of that sort. You call like .get on that method reference or that supplier, and it will go out and execute that method at that point in time. It will go out and execute that method and return you that value.
We can look it up later. So
Mhm.
let's
Sure.
move on instead.
Sure. Sorry, Swerve Auto Builder. There you go. Nice. Yeah, honestly, there's not really much to look here. But you can just see that I'm passing in method references, the locations of these get pose and reset odometry methods inside the Swerve subsystem object. Yeah. Okay. You know, I was completely expecting this because this is completely new concepts and knowledge, and this is like the knowledge that they teach in the Weed Out course at Northeastern. So you guys are doing well. All right. Thanks for asking questions. Yes.
What's the difference between using the reference and like, are you not able to call like get pose when you're executing the function or when you're executing like auto builder?
I think we have to have the code for the auto builder to actually explain that. So maybe we
Yes.
can look it up later. Just-
Like, yes, I think you can if you pass in. Oh, I know why. Because Swerve Auto Builder is not my code. If I just give it the Swerve subsystem object and be like, here you go, like you can access everything you need here. Swerve Auto Builder does not know which explicit method to call. I could have named my method inside Swerve subsystem get robot position, but Swerve Auto Builder doesn't know exactly which method to call.
Because you can't like modify Swerve Auto Builder. So
I can't modify Swerve
Okay.
Auto Builder, and it's like if I give it a Swerve subsystem, that
Yeah.
method could be named
Yeah.
anything in theory. Multiple teams could name it all different things. So how would Swerve Auto Builder know which method to call exactly? So instead of taking in a whole Swerve subsystem, it just says, give me a reference, a supplier to the position of the robot. You tell me where the location is, but not the actual, like whole subsystem.
okay.
Nice. All right, moving on. Oh, sorry. Yes.
But if you're trying to ask for the get position, don't you have to know what the name is?
Oh yeah. So at this point in time, this is my code right here. Okay. So this is my code right here. But I'm saying the Swerve Auto Builder class. The Swerve Auto Builder class is not my code. That is like a third-party thing. So I know I have the Swerve subsystem, and in this line of code, I have access to the Swerve subsystem, and I have access to the get pose method. And so I tell Swerve Auto Builder, which is some third party, where the exact location of the get position of the robot supplier is, and that's right here. More specifically, so notice that this is the Swerve Auto Builder, right? Swerve subsystem, where is that defined? Swerve subsystem is all the way up here, where I pass this in as a argument to the constructor of this class, right? And I store it up here as an instance field, Swerve subsystem, right? So I have access to this swerve subsystem, and I can tell Swerve Auto Builder the location of where these get pose and reset odometry methods are.
So let's say you wanted to call get pose like in the future, you know
Yes.
how you're referencing it. How would you actually like write out the code to?
I'm
Get
pretty
that.
sure, so actually, that's a very similar question that someone else asked. I'm pretty sure, like, if I was writing Swerve Auto Builder, this class, inside the constructor, which is, you know, you're calling the constructor right here, I would say the first argument would be a supplier of a position. And then I name it whatever, and then later on when I run the auto command, I do robot position dot get. Dot get, remember you saw that in the supplier slide? If you go here, and how like, instead of X speed function, it would probably look like robot position function, and it would be a supplier of a position. And then when I'm actually, if I was writing Swerve Auto Builder, when I want to get the robot position, I would do robot position function dot get, and that would get me the live position of the robot in this moment in time. Does that answer your question? Yeah. Cool. Anyone have any more questions? Okay. Oops. Okay. Triggers and commands. If programmers are not here, this is most likely what you will be editing, or actually, regardless of whether programmers are here or not. Say at comp, the driver says, I don't want the B button to, you know, I want to, like the B button currently is intake out, but I want to change that to the X button, please. Let's talk about triggers and commands and how they relate, okay? First off, we always use Xbox controllers on this team. And you're gonna need an instance field. You're gonna need a global instance field called, of the type command Xbox controller. And you pass in the port number, okay? So let's take a look at this line of code right here. This .driver controller is simply an instance field. Like up above, I did command Xbox controller driver controller equals new command Xbox controller port 0, right? Here, this .driver controller, which refers to a command Xbox controller, dot B parentheses, this is some method inside driver controller, dot while true. And while true will take in a new command, and whatever command I pass in here, new break command. This .swerve subsystem is passing in the subsystem that it's going to add requirements to. It's going to reserve that subsystem, right? So what does this line mean? It means the B button, driver controller .b, referring to the B button. While true, as in while this B button is held down, run this command repeatedly. And, schedule this command and have it run in a loop, right? When B is let go, it will no longer be true. Thus, it will terminate the command. It will stop the command. And remember, when it stops the command, when you let go of B and it terminates that command, it will call the end. It will call the end method right here of the command class. Okay. Okay. Now, anyone have any questions about this B button and what it does? Okay. Something a little more complex. This .subsystem controller, which again is an instance field of another command Xbox controller, .y, referring to the Y button, .toggle on true. Toggle on true takes in a command. This command is a new instant command. And this instant command takes in a supplier. How do I know it's a supplier? No, this is a lambda function, check. It has no inputs, check. And it returns, scrap everything I said. It is not a supplier. because it doesn't return a value. That's my bad. Remember how, remember how I said right here that if you, you don't have to explicitly define a return type. If you don't, like, if you just do parentheses, arrow, no curly braces, you just specify a value, that will be your automatic return type, or that will be your automatic return data for this lambda function. That's your output. However, you don't always need to return something. And how you control whether you return something or not is by slapping curly braces, because now you are defining a body to that lambda function. And inside here, I call a method called this.armSystem.armSubsystem, which is an instance field of the arm subsystem, .set level 2. We don't have to worry about what that does exactly, but notice there is no return keyword. Thus, this lambda function here takes in nothing as an input, void as an input, and returns nothing, because I have these curly braces here, I am now defining an explicit body to this lambda function, and now I can control whether to return something or not by using the returns keyword if I want to return something. But here I don't. I just want to call some method, and then it returns nothing. So what I didn't go over is what is toggle on true. Toggle on true is to contrast with while true. While true says run this command as long as the button is held down. Toggle on true simply means run this command once as long as you like pressed it and let go. Basically, like the instant you press Y, like say you're not touching the Xbox controller and then you press Y, because it went from down to up, because it went from not being pressed to being pressed, that is a toggle, kind of like a light switch, right? And it will run this command once, not continuously, just once. And then in order to activate this again, you have to let go of that button and then hit it again. That's like the whole toggle part, okay? So when Y is pressed, when it's toggle, which this command will only fire once, it will run the following command, a new instant command, where inside this instant command you specify a lambda function to run. Yeah, so to explain this in English, when I press Y, this command will run once. What command? This command will set the level of the arm once, and this command will never run again until I let go of the Y button and press it again. Okay? All right. Anyone have any questions about triggers and commands? Yes.
So when you make the lambda function in the instant command, you can make it return something. When would you want to make it return something?
If it asks you to return something, or if you want it to make it return something. It's like that's like asking like when do you want to return something in a method. It depends on what the method does,
okay.
Right? And a method and a function are practically the same thing, right? These are different names. Anyone have any more questions about? Anyone else have any questions about triggers and commands? All right. This is the last major slide that I have. Okay. Command groups. We talked about individual commands, right? Move forward, set set wrist angle, stuff like that. But oftentimes when you're actually creating an autonomous group, you don't want to run things one by one. You want to run them at the same time. Or you want to run things continuously until one command finishes. Or you want to run 5 things at the same time until all of them finish. There are a bunch of command groups that will handle this logic for you. Let's go over them, okay? Sequential command group is your first one. Sequential means in order, right? So the commands that you specify here will run in order. And so what does that mean? You tell it to run one command, and it will run that command. Oh, sorry, you create a sequential command group here with, in this case, two commands, command 1 and command 2. What it will do is run command 1, wait for command 1 to finish, and then run command 2, and then wait for it to finish. And then by that time, the entire command group is finished, okay? There are two different ways to create that sequential command group. One's the old way, one's the new way. Either you can create a new sequential command group object and pass in the commands that you want, or commands dot sequence those commands. Yes? Anyone have any questions about sequential command group? All right. Parallel command group. This runs, if you pass in command 1 and command 2, it will run both of them at the exact same time, and it will wait for this parallel command group will finish only if all of the commands inside are finished. So it will wait for command 1 and command 2 to finish before moving on. Okay? Anyone have any questions about parallel command group? Yes.
Is commands a library? What is that?
It's a class, and this is a static method. I don't know if you guys talked about static methods, did you, in AP Comp Sci? Kind of, like math.random, stuff like that.
Yeah.
Yeah. They do the same thing. Don't worry about it, right? Parallel deadline group. Parallel deadline group is like a special command group where you run command 1 and command 2 at the same time. It's parallel again, so same time. However, the definition of when this command group finishes is different. This command group, this parallel deadline group, will end when the first command that you specify ends. Okay, so say command 1 runs for 5 seconds and command 2 runs for 10 seconds. They will start them at this parallel deadline group will start them at the exact same time, but after 5 seconds has elapsed, command 1 has now finished. Command 2 is still running. It still has like another 5 seconds left to go, but it doesn't matter. Once the first command finishes, it will terminate all other commands. So command 2 has now been, terminated part way, and then it will move on to further commands. All right. Anyone have any questions about parallel deadline group?
When you
Yes.
say, sorry, when you say first, do you mean like one of them, right? Just one of them. It doesn't have to
No.
be the first.
No, first.
Has
As
to
in
be
the
command
order-
1.
The
Oh,
order
okay.
of the arguments matter here.
Okay.
Yeah.
That's good to
Anyone have
know.
any question? Yes.
So what's the commands.deadline? Like, what would that do?
Is the same thing as it's just to create that command group. It is the same thing. It will return you a new parallel deadline.
Oh, okay.
It like underneath the covers, it will return you a new parallel deadline, like a new object. Yes.
So why run a parallel deadline group if it's just going to end when the first command ends? So why not just run the first command?
Well,
Well, it runs
say
partially.
for example, I'm running an auto path, and actually, sorry. An example of when sorry, are you asking like when is an example basically of when you'd use
Like
parallel?
kind of like why not just all or nothing? Why?
Why
some
only
or
the first one?
Hmm?
Why only the first one?
No, like why not all or nothing? Like why do you need to run the first and then run a little bit of the second one, but not all of them, or just none of the second?
Oh, okay. Why all or nothing? That's just kind of how the command group works. It is similar to parallel command group. A parallel command group will run all commands at the same time. All commands that you specify, at the same time.
Wait, no,
Yes.
sorry. No, like, why do you need to run just a little bit of command 2? And, like, you don't even know how much of command 2, right?
Right. So it depends on your context. Like all of these command groups depend on what you're trying to do. An example of a parallel deadline group.
Intake is a good one.
Yeah, hold on. Parallel deadline group. I want to find parallel deadline group. I want to find one that doesn't have a wait command.
Well, wait command can explain it very
Okay.
easily, I think. It's like, you have a wait command, which is essentially just a timer. And like, you can set that to another thing that would run at a finite amount of time, but like if you wanted the intake
Yeah,
to
I guess.
run for 2 seconds, then you run that in tandem with the wait command. And
Yeah.
then you just continuously run the intake until the wait command ends. And then you can actually finish the intake command at a fixed time.
Yeah. So the reason why you can't just run new intake command, the reason why you can't just run new intake command is because of how we coded the intake command. When do you want an intake command to finish? You call intake command. When do you want it to finish? That question is sort of arbitrary because it kind of depends on what you want to do, right? Like ideally, how we constructed this intake command is finished will always return false. Okay, it will never like if you just let it go and don't touch anything, it will never stop running. So now we wrap this in a parallel deadline group because the first command that we specified is a wait command of 1 second, and then the second one is new intake command. So when it runs this command group, it will run both commands at the same time. Okay, so you got a timer going for 1 second and intake command continuously running, just doing its thing, never stopping until the wait command finishes, and then the deadline group will terminate all the commands and only run intake command part way. Does that make sense?
Yeah.
Cool. Okay. Yeah.
I noticed that the command groups are also commands. So
Yes.
can you put that command group inside of a command group?
That is exactly what this thing down here is. You can nest these commands. These command groups are, yes, they actually return commands. Command groups are commands in themselves. So you can nest a whole bunch of commands. You can see here we have a sequential command group running a whole bunch of commands in parallel. The first one is a deadline group. And then the second one is running a trajectory, third one's running a trajectory, and then the fourth one is another parallel deadline group. Yeah, so you can nest these. Anyone have any questions? Okay. And so just to clarify these command groups, I had an idea of, give me an example of what is like a real life auto that you want to see, and I'm gonna code it up for you live on the whiteboard. Just like a general mock-up of what the command groups would look like. Yeah. So anyone have any ideas? Raise your hand. What is like an auto that you want to see?
Out of our robot, just think about that robot. Like what can it
Honestly,
do?
if you had 254's cheesy poo food robot, any
We
theoretical
don't have no
robot,
idea what it does. so-
yes, trust me.
So if we're assuming it's like last year or this year's game,
You can, yeah, sure.
then like taxi out and then pick up a cube and then go onto the balancing pad.
Yes. Charge station, right? Okay. Taxi out, pick up cube, and go on a charge station. Okay. So I would say it would be something like you want a sequential command group. Here, where the inside, the first command that you want to run in the sequential command group is taxiing out. It'd probably be like some run trajectory command, and we pass in the taxi trajectory. This is all just pseudocode. So you run this trajectory command. Let's see, taxi trajectory here, like this would be like part 1, right? So you'd want to go, actually you tell me, are there going to be 2 parts? Are there going to be 2 parts to the trajectory, or is it all one continuous one?
One continuous.
One continuous one? Okay. So this run trajectory command we're gonna want a yeah, how about something like this? So we're gonna do a parallel deadline group here. The reason why is because we want the following commands all to finish when the first one is finished. The first one is gonna be a trajectory, like I don't know, trajectory follow command, and we'll follow the taxi and pick up taxi to cube and back trajectory, right? And while it is running this trajectory follow command, we probably want to continuously run the new intake command, right? Because we want to continuously run the intake so that when it taxis to the cube, the intake's already running, and then it will pick up the cube and spin around or something, come back, okay? And then we want to spit out the cube, right? But spitting out the cube is the intake command, but remember, intake command does not finish. So what we need is another parallel deadline group where the first one, where the first command here is a wait command. And say we take half a second. Say we take half a second. Sorry, let me compress this a little bit. What?
Remove space after this time.
Okay. Yeah. So say we wait we wait half a second, and we also do intake command, like I don't know, direction.out, so that it can differentiate between intaking in and intaking out. Okay. So this parallel deadline group will now run the out intake for half a second, and then we want to go onto the charge station, which would be a trajectory follow command, where it goes, like go onto charge station, like whatever the path is. And that is your auto command group of taxi out, pick up cube, go on to charge station. Yeah? All right, yes, question?
Wait, you asked Justin for continuous taxi or 2 parts taxi?
Yeah, so I did ask for continuous, but then it would be like, when do I drop off the cube?
Like, is it if it's 2 parts, would it be like it'd have one deadline group to go to the cube and then another to go back and drop it off?
Okay, yeah, so yeah, that was a little bit confusing because I changed, like in my head, your request of having one continuous path. So what this assumes is that you have one path that goes from the starting position to the cube and back, and then you execute the command to drop off the cube, and then you run another trajectory to go from whatever position you're at right now to the charge station.
Okay.
Yes?
So does the taxi to cube and back path, does that go just to the cube? And then once it stops, it takes in the cube?
No, so this is assuming that your path, this taxi cube and back path will start and drive to the cube and back. So that is one continuous path, okay? And what it's doing is all this time that it is driving this path to the cube, it is also running the intake command. This is a parallel deadline group, so it will run all commands in parallel. Yeah, so constantly running the intake and following this command, following this trajectory. Once the trajectory ends, it will terminate the rest of the commands, and including this. Yep. All right. Anyone have any final questions about anything?
Wait, what would it look like if it was 2 steps?
Right now it's 2 steps.
You just have
Right
two
now it's
different
2
paths.
steps.
Two steps like
one
the
that
taxi to
gets
cube and back, like split that into taxi to cube and taxi back.
You have
What do
two
you mean?
paths. You have one that gets the cube, one that comes back to home. In this, you're just going there and then coming back in the same path.
Yeah, I guess if it was 2 parts, would you need the parallel group because you wouldn't have to run the intake on
You
the way
wouldn't have
back?
to run it the whole time. You just have to get there and then run up and then come
Yeah.
back.
Yeah, so it would look something like this. So let's see, I'm
You get
gonna
the same
remove this, and so we're going to run the trajectory follow command to trajectory follow command, yeah, taxi to cube, right? And then right there, we're gonna stop and intake and then intake it. And that's gonna be a parallel deadline group, because again, the intake command does not finish, so we need something to force it to finish. Wait command, 0.5. So it's gonna intake it for half a second. This is all purely theoretical, right? And then we're gonna run another trajectory follow command to taxi back to, I don't know, what
Taxi back to start.
Yeah, to start. And then we're gonna spit out the cube, and then we're gonna run the trajectory to go on the charge station. Does that make sense?
So is this 2 steps?
Yeah, well, this is two different, now this is like 2 different trajectories. This is one trajectory to go to the cube, and then intake. Like at this point in time when you're intaking, the first trajectory has already ended. And then the second trajectory that you're running is taxied back to the start. That make sense?
Yeah.
Cool. Anyone have more questions?
Want to try another one?
No.
No. Okay.
All right. Yeah, that's all I have, and I will answer any more. I'll talk about more in depth about any individual questions about like suppliers and lambdas and all that stuff. But in that case, that's all I have for my presentation. Yeah. Thank you.